Okay, so this one over here, you guys remember we started talking about, like here, we multiplied what our e to the x power was and what our sine of x was, and then we just multiplied pieces until we found the first three terms. We're going to do the same idea with these, except for we're dividing sine over cosine. So sine, even or odd function. Odd, so we're only using the odd powers. So the first odd power would be what? 1x to the first, right? So just x. And then our next one is going to be x cubed over 3 factorial, or x cubed over 6. And the next one will be over 5 factorial. Seems like a lot of mental math. And then x to the 7th over 7 factorial, and so on, right? And then our cosine is even. So our first even is what? 1. Our next even is, so I'm just going to put 2 there. And our next one will be x to the 4th over 4 factorial, and so on, right? So you just do long division with these, so you won't want the factorials. And I only want the first 3, so I'm guessing we'll be okay with like 3 of these. Isn't there somewhat? And then, yeah, they oscillate between positive and negative. So this one was positive, so this is going to be minus. That one's positive, this is going to be negative, plus, minus, plus. The next one will be minus. There we go. Thank you. And the next one here would be minus if we need it. So this should be a negative here. What is 4 factorial? 24, sound good? Okay, and then if we need more, we can always add another one in there if we're feeling like we're missing it. And then this one's the one that goes underneath, right? And typically we have placeholders. I don't think we'll need them here, so we'll see what happens. 5 factorial, that'd be this times 5, right? So 120. And I'm just going to stop there and see if that's enough. So now if I start my long division, you're just looking at what do I have to multiply this by to get this, so it'd be x, and then you take everything out here times x, which gives me x minus x cubed over 2. Let me know if I do something wrong. I don't have my notes in front of me. Plus x to the 5th over 24. And then what do I do with those? Subtract them, so I'm going to need way more terms, right? So subtract this, this goes away. Add this, and subtract that. And then what do I do after I subtract those pieces? Yeah, and you bring the next term down, right? This one here is 7 factorial, so that will need figured out. But then that term comes down. Do you guys know how to finish that, or do we need to spend time doing that? I don't think they would make it, where the numbers are maybe this terrible, but you just never know what you'll see. Just keep going with it. Okay, so times by x, and then we're going to subtract these. So this turns into a plus, so we've got negative a 6. And then this turns into plus a half, right? What's that going to be if I take plus a half? 2/6 or a third, right? So this would be x cubed over 3. Same idea with this one, so we're just dealing with those fractions right now. So we've got 1 over 120 minus 1 over 24. 1 over 24, what do I need to multiply by? 5. So we get minus 5 over 120, which gives me negative 4 over 120, which would reduce to negative 1 over 30. And then this is a minus, correct? I didn't mess that up. And I'm just going to leave it like this for the moment because I don't think they're going to give you fractions that are, and they're not terrible, obviously, but I don't think they're going to give you things that'll go out to 7 factorial because they don't typically do that much mental math. They usually leave those things. They're sneaky about leaving them that way. So our next term at the top is going to be what? X cubed over 3. And then we take that and we times it by this whole thing here. So we might need our next term. So this was x squared, x to the 4th, so now we're at x to the 6th over what? 6 factorial. And then times it through here. And we get x cubed over 3 minus x to the 5th over what? 6. And then we've got here, oh, I feel like I messed something up here. Yeah, for sure did. Hold up. Because up here, when I multiply my x through, I just multiplied it to the 3 pieces I'd written, but I'd have to also multiply it by this one, wouldn't I? So that's going to be minus x to the 7th over what? You just have to be careful that you go enough spots out. Because, like, eventually the terms aren't going to matter, those back ones. But, yeah, you'd have to, like, extend this out a little bit. I've never seen them do a long division one on the AP test. I'm just nervous that not often, probably once. But you just never know what they're going to do. So, yeah, you have to be careful here. So we'd probably go a couple more spots out. But do you see how ridiculous these numbers are? They're not going to give you things that'll give you, like, a 7 factorial minus a 6 factorial without your calculator, you know? These things would go on forever, like to the right. Is that what you're saying? Yeah, because there's an infinite number of terms that you're using. So they're going to go on forever to the right, but we only want the first 3 non-zero terms. Yeah. Well, and right here, is this x cubed over 3 going to be correct the way we have it right now? Yeah, even without correcting this, this part's right. So we already know 2 of them, and so maybe they'd just say the first 2, and then we've got the first 2 there. But yeah, we would need, do we even need this one though for the correct to 3? We wouldn't end up needing to, figure this out, but that value there isn't correct, what we wrote down. Do you see what I mean? Like, I don't want you super confused there, but let's just pretend it says 2, okay, and then we're done with that problem. But you see how you'd have to go. Yeah, and they do that where they say find the first 2 or the first 3. They don't usually go where you have to find a bunch of them. And do we put a dot, dot, dot behind this for our answer? Or this one here? No, because it's just saying find the first 2 or find the first 3, okay? Now, in your email, I sent you recordings for 48 and 66, and they're explained very well. So watch those recordings tomorrow, okay? And you can learn how to do those. Those will go with your homework. The homework's not in this one, but there's homework problems that go with those 48 and 64 and 66 there. Let me look here. So the homework problems that go with those are like here. 47 and 49 are a lot like 48, and then 63 and 65. And I think I even put 63 in a recording for you. Try it yourself, but then watch the recording and make sure it makes sense there, okay? And number 1 I did in a recording for you. So that one, you're going to, like 1 through 5, you're doing 1 through 5 odd. 1 through 4 are like really difficult concept type problems, but they're very good concept problems that they like that type of wording on the AP test. So I know it says 1 through 5 odd, but you might want to give like 2 and 4 a try, or at least think your way through it. And I sent you guys like the answers, right? So you could check stuff. That was in an earlier email, so make sure that you're checking to make sure that, you know, you're doing things correctly there. If you're needing to find a radius of convergence, if you do your a sub n plus 1 and you multiply by the reciprocal of your a sub n, so you have to get it in this form here first to find what those pieces are. And that we might need to practice a little, is just getting it into that form. But then you just apply your ratio test like what we were doing in the last unit there. Same chapter here. And then you cancel it out. We end up with this, which goes to 0. 0 times anything is always going to be less than 1, so your radius is infinite. It doesn't matter what that value is. It's always going to be less than 0. So a lot of these will probably, end up with a radius of infinite, but that doesn't mean it's always going to be an infinite radius. Okay, we're going to take a look at 4. Find the Taylor series for f centered at 4. What does this even mean, this notation? What does this notation mean? It's, the nth derivative, right? So we're going to need this in order to, like, plug it into my rule. And we're centered at 4. So instead of, like, having your x to the 0 and then x to the 1 and then x squared, you're going to have what instead of those? X minus 4 to those powers, okay? So I suppose I can just start getting some of this set up. So the x minus 4 to the 0, let's not write that one. X minus 4 to the 1. X minus 4 squared. I'm going to give myself some space so I'm not cramming stuff in here. We're dividing by what? Like for this one, we always divide by 1 factorial. This one we're dividing by 2 factorial. 3 factorial. When you're not sure what to do, just try to get something, started, because once you start, your brain starts working, it starts making some connections there. Okay, so this is our start to it. At least we got the x minus 4 part done. Got our factorials in there so we don't forget them. And then what do I multiply this one by? We'll work back to the first one in a minute. Don't forget this one, okay? We're going to plug in 1 for our n, right? Because that would be our first derivative. So if we plug in 1 for our n, is it going to be positive or negative? Negative. And then 1 factorial will give me, so I suppose I can write this up here. So I would get negative 1 times 1 over 3 times 2, so 6. So we get negative 1, oh, did I write that wrong? 3 times 2, and I said 3 times 2 and then said 6, and there we go. So I get negative 1/6. Does that look okay to everybody? We can clean it up in a minute. The whole idea is to make sure we can get these pieces. So then our second derivative at 4 is going to be when we plug 2 in. So if I plug 2 in, it's going to be positive. The numerator is just going to be 2, right? And then this piece is going to be 9, and this piece is going to be 3. So 2/27 and positive, right? Just making sense what I'm doing? When you read the question to number 4, it's like, I have no idea what it's asking me. And that's very typical when you're starting to do these things. Once you start understanding the whole, how they write questions and what it's asking you to do, and you do a bunch of problems, it'll get easier. But I feel like this lesson is very hard to just jump into the homework and go, I know what I'm supposed to do here. Okay, so the third one, let's get that one. And then we can go back to the 0 one. So we're plugging in 3. It should be negative 6 on top. Does 3 factorial sound good? And then this is 3 to the third, which is 27, and 4. So I suppose the 6 would go into, 6 reduces to 3 times 2. So the 3 will go away here and make this 9, and the 2 will go away here and make this 2, so I get negative 1/18. Pretty sure on that. And what's it saying here? Find the Taylor series. We might end up trying to write this in the sigma notation here too. That way we can do our radius of convergence. Okay, can you go back and do the first one then? We get 1. Sorry, my slate just stopped working for a minute. So this is 1, that's 1, 1, 1. Yeah, so 1 looks good. And the x minus 4 is to the 0, so it's not there. We divide by 0 factorial. I just don't want you to forget that one there. So questions on what I've got going on here? And we can continue and write more of them if we wanted to. Now this is like my n equals 0, and this is my n equals, this is my n equals 3. I'm wondering, actually, I could probably use this to really help me write it in sigma notation. And this I always have to think through. There might be a more, efficient way to do this and stuff, but each problem's different, so I always just think my way through it. It's oscillating between positive and negative, which this negative 1 piece will do. So really, isn't the nth derivative always this piece that's out front? So this nth derivative, that whole thing can just be written in here. That's going to go with every single term, because we put the nth derivative for that term in front of it. This right here. But then we need these pieces here. So then I need to multiply it by x minus 4 to what power? Well, this is to the 1, and this one's to the 2, this one's to the 3, so it's to the n power, isn't it? And then we're always dividing by like 0 factorial, 1 factorial, 2 factorial, 3 factorial. So we're dividing by n factorial. And can't I simplify this a little by canceling out the n factorials right away? Okay, so you could cancel those out. So you're probably not going to see that if you look in the answer book where there's a factorial there and a factorial there. So I would say it's going to look like this. Is there anything else that cancels that I'm missing? I don't think so, right? And then can you find what your a sub n is and what your a sub n plus 1 is? And find your radius of convergence from there. So I'm going to give you a couple minutes to wrap your brain around this and ask questions, and then if you feel good about that, go ahead and try to find your radius of convergence. We'll do that here in like 2 minutes. So to find your radius, you need these pieces. The negative pieces are going to end up going away because we put absolute values. It's asking for it, isn't it? Yeah, what is radius convergence? And this just turns into n plus 2 here. So then you take your limit as your n goes to infinity, put absolute values. I'm not even going to write the negative 1 pieces. This one goes first, which being your x minus 4 to the n times x minus 4 to the 1. This turns into 3 to the n times 3. And then we've got our n plus 2. And then reciprocate this one here. The negative 1 piece, again, I'm just leaving off. If you want to write it and cross it off, it's kind of fun to do. Okay, so we get this to cancel. We get this one to cancel. The x has to stay in the absolute value, so we end up with the limit Don't forget about the 3 down here, so we have n plus 1 on top over 3n plus 6 you could write, or you could leave that in parentheses. It's up to you. And then the absolute value still has the x minus 4 there. Does that look okay to everyone? What is this limit going to? A third, right? So we've got 1/3, the absolute value of this. And what does that have to be less than? 1. So I would multiply by 3 here first, and we get the absolute value of x minus 4 is less than 3. So my next step to find the radius is to do what? Put it between -3 and 3. And then add 4 to all of them, right? So if we add 4 here, we just get 1. Add 4 here, we just get x. Add 4 here, we get 7. So it's got a width of 6, so what's my radius of convergence? 3. Which you can kind of see in this step here. Some people just get confused and they're trying to look at the wrong step, so I just always go to the end there. Hopefully that's all the right answer. I never checked it with the book here. But number 4, our radius is 3. Yep, so that part looks good. And then let me check up here to make sure that all looks right. N equals 0 to infinity. Yeah, and they just wrote this piece in the back of it. It doesn't matter if it's in the numerator or the back, so. Okay, you will have questions when I come back. I know, that's fine. Okay, if you get stuck where you're like, I really cannot do any more problems, do some more problems that you know how to do. I know that seems kind of counterproductive, but at least then you're practicing the stuff over and over. It'll make it a lot easier on your AP test.